conversation. Many of the great minds of physics were occupied with attempted solutions to these problems. Einstein most admired the work of Hendrik Antoon Lorentz, a Dutch physicist who had constructed a masterful theoretical extension of Maxwell's physics, combining those equations with the recently discovered electron. Einstein and his circle of friends eagerly discussed the work of Lorentz and others, carefully studying papers that appeared in journals such as the prestigious Annalen der Physik coming out of Germany, or the Annals of Physics. Journals such as the NLM were the lifeblood of science. Whether someone had carried out a new experiment and found a new theoretical explanation, it hardly mattered unless they told someone about it. Sometimes these could be done in person at conferences or similar events. The scientific groups that organized meetings were often nationally oriented, such as the German Physical Society, the French Academy of Sciences, or the Royal Society in Great Britain. It was not always possible to attend, and who wanted to wait a year until the next meeting. So these scientific groups often published journals in which scientists reported their latest work. Thus, like Einstein, or someone far removed from the centers of scientific work, could still keep up to date the latest developments through the mail. The scientific community was defined, in a large sense, by where these journals could travel. The French scientists could feel as though they were participating in German research, reacting to developments, and contributing their own ideas. These papers in these journals provided Einstein the opportunity to argue with Mileva, Michel, over equations of electromagnetic optics, the validity of mathematical transformations, and the proper interpretation of experiments with giant electric coils. Many of the papers were incremental additions and adaptations of either theory or of ether theory. Very few scientists had the virtuosity seen in Lorentz's attempts to overhaul the whole system and grasp the most fundamental principles at work. Ether theory accumulated a number of strange puzzles, though no one truly doubted it. It was a hypothesis that led to the greatest triumphs of physics, from electrification to radio. How could it be wrong? Even Lorentz became frustrated on occasion about it. He wrote down a series of equations now called the Lorentz transformation that made some of the puzzles go away,